Hello everyone, and this is Priyanka from Edureka, and in today's tutorial we are going to cover one of the most important algorithm in machine learning, and that is random forest. Now random forest is versatile because it could be used both for classification and also for regression problems. So keeping this in mind that random forest is so important, today's agenda is based on that lines. So we will be covering what exactly is random forest, where we will understand this with the help of a very simple example. Then we will understand why to study decision tree and what is actually decision tree doing in random forest. And then we will cover certain important terms in random forest. And finally, we will move forward and see the working of random forest, how actually does random forest work, and what are the various functionalities that goes behind a random forest algorithm. And moving on forward to understanding the various advantages and disadvantages of random forest. And the advantages also cover that why random forest is so popular algorithm. Okay, and then lastly, we will take into account practical demonstration and hands-on on random forest classifier in our Jupyter notebook, and we will be working in Python. But before we get started, make sure you subscribe to Edureka's YouTube channel and hit the bell icon to never miss an update. Also, if you're interested in online training certification, do check out the link in the description. Okay, so now let's understand what is a random forest. So random forest is constructed by using multiple decision trees, and the final decision is obtained by majority votes of these decision trees. So let me make things very simple for you by taking an example. Now suppose we have got 3 independent decision trees. Here we are just taking 3 decision trees. And I've got an unknown fruit, and I want that these trees would give me a result of what exactly this fruit is. So I pass this fruit to the first decision tree, the second decision tree, and the third decision tree. Now a random forest is nothing but a combination of these decision trees. So the results are being fed into the random forest algorithm. So what it sees is that, okay, the first decision tree classifies it as peach. The second decision tree says that it is an apple. And the third one says that it is a peach. So random forest classifier says that, okay, I've got the result as 2 peach and 1 for an apple. So I would say that the unknown fruit is an peach. Alright, so this is based on the majority voting of the decision trees. And that is how a random forest classifier comes to a decision of predicting the unknown value. Okay, so this was a classification problem, so it took the majority vote. Now suppose if it was a regression problem, it would have taken mean of it. Okay, so now let's move on further to understanding what is a decision tree. But before that, we should understand that random forest, the building blocks are decision trees. And that's why studying decision tree becomes important, because if we understand one decision tree, we can apply the same concept to random forest. Okay, so let us understand what is a decision tree. So decision tree has basically 3 nodes that are important. The first one is the root node. The root node, as the name suggests here, the data set, the entire data set is fed at the root node. And then there are decision nodes where decisions are being taken and splitting is performed. And then we've got the leaf node, and these leaf nodes are the ending point of the tree where no further division takes place. And we can say that the predictions are made at the leaf nodes. Okay. Now, another thing to note here is that decision nodes provide links to the leaf nodes, and decision tree breaks the data set into smaller subsets. Splitting is done at nodes, and at the end of the tree, the final point, the decision or the prediction is made. Now let's construct a decision tree and take an example of the penguins classification. So let me just walk you through what is this penguin classification problem. So we've got some 3 species of penguin. Let us get familiar with these penguin species. This is 𝐵𝐸𝐻, this is Adelie, and this is chinstrap species. So these are the penguin species of Antarctica, and they are found on different islands. So we have to classify these penguin species correctly. So we're using random forest here, but for convenience sake, let us just work with decision tree right now, and we will see how a decision tree really classifies these species. So that's really interesting. And let's move on forward and understand some parts of this penguin, because we'll be working with this data set. Okay, so this is a penguin, and this is the head, bill, flipper, belly, and claws, the different body parts of the penguin. So we are majorly concerned with the bill and flipper and the body mass of the penguin, because our data set contains majorly of these features. So make sure that you understand the flippers and also the bill of the penguin. Okay, so now moving on forward, and let us now construct a decision tree. So let's see how a decision tree is constructed. So I have taken a subset of the penguin's data, and here we see only two columns, that is island and body mass, and of course the species of the penguin, that is the outcome or the target variable that we have in this subset. So now we construct a decision tree here, and we take body mass as the first feature. And the splitting is done based on one condition, that if the body mass is greater than equal to 3500, and if it is yes, then based on island, the another feature, we will classify or get the leaf node as either 𝐓𝐫𝐚 or 𝐵𝐲 island. So if the island is either 𝐓𝐫𝐚, then the species would be Ederle, and if the island is 𝐵𝐲, then the species would be 𝐵𝐸𝐻𝑚. So after 𝐓𝐫𝐚 and 𝐵𝐲, no further division takes place because we are getting the predictions at these leaf nodes. Whereas if the body mass is less than equal to 3500, and it says that yes, the body mass is less than 3500, so we get the species as 𝐶hIN-strep, and so no further decision had to be made at this node, and that's why it was being ended here. So this was a very simple basic example of a decision tree. And suppose if we had got a huge data set, this decision tree would have gone into a huge depth, and the depth of the decision tree would have led to overfitting of the data. So that is one of the drawbacks of decision trees that random forest overcomes. So now let's move on forward and understand the important terms in random forest. And this will also help us consolidate whatever we have learned so far. So we've taken the same small decision tree of the previous example, and let's understand these are also the important terms which will be relevant to random forest also. So the first is the root node. Now here what happens is that the entire training data has been fed to the root node. And then we've got here that each node will ask either true or false question with respect to one of the feature. And then in response to that question, it will partition the data set into different subsets. That's what it is doing here based on the condition that if the body mass is greater than equal to 3500, it asks a question either yes or no. And based on that, again, further partition is done. And if not, then it just classifies the species. And then again, what happens is that the splitting. Now, this is very important here. The splitting takes place either with the help of a Gini or entropy methods. And these helps to decide the optimal split. And we will be discussing about splitting methods very soon, right? Okay. And then we've got the decision nodes, which provide the link to the leaf nodes. And these are really important because then only the leaf nodes would tell us what actually the real predictions or to which class does the species belong. So now coming to the leaf node, and these are the endpoints where no further division will take place and we will obtain our predictions. Okay. So now coming up to another important thing here is working of random forest. So now for working of random forest, we will have to understand a few important concepts like random sampling with replacement, feature selection, and also the ensemble technique, which is used in random forest, and that is bootstrap aggregation, which is also known as bagging. So we will understand this with the help of an example, which will be very simple. And then we will go on understanding how feature selection is done in both the classification and the regression problem. Actually, how random forest select features for the construction of decision trees. Well, in random forest, the best split is chosen based on Gini impurity or information gain methods. So this also we will understand. Now let us first understand random sampling with replacement. Now what happens here is that we have got a small subset of the same penguin data set, wherein we have got some 6 rows and 4 features, that means 4 columns. And the arrows that you can see is that now we will be creating 3 subsets from this small subset, right? And these 3 subsets will become our decision trees. And then we'll be constructing decision trees from these subsets. So let us create our first subset. And you can see here that the subset is randomly being created. And for convenience sake, let me just also show you the different subsets here. Okay, so now for better understanding, let us understand this, that in the first subset, if we focus, we've got certain random rows here and we've got certain feature, but we do not know how this feature has been selected. We got island and we got body mass, but in the second subset, we got island and flipper length, And in the third subset, we got body mass and flipper length, right? Now let's look at the rows. Now, when I am talking about these features, I will say this is feature selection. And remember this term. Now coming to the second concept, that is random sampling. Now random sampling is nothing but selecting randomly from your subset. So I'm selecting randomly certain rows from my subset and creating further subset. Okay, so what is replacement here? Replacement can be seen here and can be understood with this second subset. We see here that the 𝐵 species, this row is being repeated again. And this is replacement. That means that when we are working with repeated rows and this row can be repeated again in the second or the third subset, then this is random sampling with replacement. That means my random forest can use a row multiple times in multiple decision trees, right? So this is the basic concept of random sampling with replacement and feature selection in random forest. Another important term which I would like to bring into the notice is that when we are working with these type of small subsets, these are also known as a bootstrap data sets. And when we aggregate the results of all these data sets, it becomes bootstrap aggregation. So just filling in the gaps so that later on the concepts become more clear. So now let's move on to drawing decision trees of these subsets, okay? So let's draw the decision tree of the first subset. Again, we are taking body mass as the first root node, and then based on a decision like if the mass is greater than or equal to 3500, then take a decision either yes or no. If it is no, then the species is 𝐭-𝐻, and if it is yes, then again you partition based on island, and if it is 𝐸, then it is Adderley, and if it is visco, then it is 𝐵 species. Okay. So this is how we will construct two more decision trees of the remaining subsets. So on the second subset, let us just again create decision tree. And here now we are taking flipper length, and then based on a condition that if the flipper length is greater than or equal to 190, then make a split. If it is yes, then the species become 𝐵2. And if it is no, that means again make a decision based on island, and if it is 𝐸, it is Adderley. And if the island is dream island, then it is a 𝐭-𝐻 species. So this is how the decision tree of the second subset has been created, and this is how it will take decisions, right, based on the tree length, depth, and also the features it is selecting. Okay, so now let's create the third decision tree of the third subset, and we get a decision tree something like this, wherein body mass, if it is greater than 4000, and if it is yes, then clearly it is a 𝐵2 species. And if it is no, then again make a partition with respect to flipper length, another feature here. And then if it is again greater than or equal to 190, then the species would be Adderley, else it would be 𝐭-𝐻. So this is how decision tree 3 will make a decision. Now let's just keep these decision trees with us, okay? And we will make sense of these trees just in a while, okay? But before that, let us understand how feature selection is done in a random forest. How am I selecting the columns? So for classification, by default, the feature selection is taken as the square root of total number of all the features. Now suppose I've got here 4 features. So it is a classification problem. I will take the square root of these 4 features, which becomes 2. So decision tree would be constructed based on 2 features each. If suppose I had 16 features, then it would be square root of 16. That would be 4. So 4 features would be taken in each decision tree. All right. And suppose if this would have been a regression problem, then by default, what would happen? The features would be selected by taking the total number of features and dividing them by 3. Okay. So this is how by default the feature selection is being done by a random forest. Okay. Now let us move on forward to consolidating our learning. So now we are coming to ensemble techniques, that is also known as bootstrap aggregation. Random forest uses ensemble techniques. And what is ensembling? It just means that you are aggregating the result of the decision trees and taking the majority vote in case of classification and the mean in case of regression problems and giving the output. Okay. So now we have again plotted all our decision trees here. And below we can see that there's an unknown data and I want to predict the species of this data. So what will happen is that again, let us just feed this problem to each of the decision tree and let's see what each decision tree makes the prediction. So I just feed this unknown data to decision tree 1, and it says that, okay, the species seems to be 𝐶𝐻. Okay. And then decision tree 2 says that based on the data, it has been found that this species is Edureka. And then decision tree 3 says that, no, with my decision tree, this species is 𝐶𝐻. Okay. Now, all these data is being fed to random forest classifier. And it says that, okay, for 𝐶𝐻, I've got 2 votes. For Edureka, it's got 1 vote. So the new species would be 𝐶𝐻, right? So this is how the Bootstrap aggregation is done, based on the majority voting and the decisions taken by different decision trees. They have been combined together, aggregated, and we get an ensembled result in the random forest. Okay, so this was a very simple concept of ensemble techniques, which has been used in random forest. Okay, so now let's move on forward to splitting methods. So what are the splitting methods that we use in random forest? So splitting methods are many, like Gini impurity, information gain, or chi-square. So let's discuss about Gini impurity. So Gini impurity is nothing but it is used to predict the likelihood that a randomly selected example would be incorrectly classified by a specific node. And it is called impurity metric because it shows how the model differs from a pure division, right? And another interesting fact about Gini impurity is that the impurity ranges from 0 to 1, with 0 indicating that all of the elements belong to a single class, and 1 indicates that only one class exists. Now value, which is like 0.5, this indicates that the elements, they are uniformly distributed across some classes, right? Now moving on forward to information gain. Now this is another splitting method which random forest can use, and information gain utilizes entropy. So entropy is nothing but it is a measure of uncertainty. So information gain, let's talk about that first. So the features they are selected that provide most of the information about a class, right? And this utilizes the entropy concept. So let's see what is entropy. This is a measure of randomness or uncertainty in the data, right? So we will understand this entropy with the help of a small example. So don't worry about it. So let's understand this entropy. Now suppose there's a fruit tray with 4 different fruits, right? And what do you feel about the entropy here? That means the randomness of the data. Is it really easy to classify these fruits into the respective class? So this becomes really uncertain and the data looks messy here. But what if we just split here these into 2 trays, wherein the first tray would have peaches and oranges, and in the second tray will have apples and lemons. So now this becomes a little more certain. We get low randomness here, and this is called as low entropy. So when we move down from tree, that means from root node to the leaf nodes, the entropy reduces. And we can also calculate information gain from this entropy. That is the difference in entropy before and after the split. That is known as information gain. Okay, so once we move down the tree and start reducing the randomness from the data, the entropy becomes lower, and that is what we want in our data. If there's low entropy, that means we are likely that the predictions would be more accurate, and we can make predictions very easily as compared to very messy data which has high entropy. Okay, so that was about entropy. So now let's move on to understanding the advantages of random forest. And we see here various advantages. So let's focus on firstly low variance. Now, since random forest overcomes the limitations of decision tree, and it also has the advantage of low variance because it combines the result of multiple decision trees, and each decision tree is being trained on limited data set that we have seen earlier also. So each tree was making its own subset of data and training the data on that limited length of the tree. So there's less depth, there's less overfitting, and low variance of the data. So coming to the next point, that is reduced overfitting. Again, since we were working with multiple decision trees, hence reduced depth of the tree, so we get reduced overfitting. That means the model is fitted well and it does not tries to learn even the noises, right? So we use the bootstrap aggregation or bagging here in random forest, and that is why we also get reduced overfitting in random forest. And this is one of the reasons that why is it so popular, because you don't have to worry about overfitting of the data, right? All right, now moving on forward to the another advantage is that the normalization is not required in random forest because it works on rule-based approach. right? And another advantage is that it gives really good accuracy, which we will also see in our hands-on. It really gives very nice predictions, either precision or recall, and generalizes well on unseen data as compared to other classifiers or machine learning classifiers which are present like naive Bayes or SVM or KNN. Random forest really outperforms other classifiers, right? So let's move on to understanding few more advantages of random forest. Is that it is suitable for both classification and regression problems, and also it works well with both categorical and continuous data. So you can use it well with any of the data sets, right? And it performs well on large data sets, right? So it solves most of the problem. That's why random forest is largely been used in machine learning problems. Now moving on forward to certain disadvantages of random forest. So the first disadvantage is that it requires more training time because of the multiple decision trees. If you've got a huge data set, you would be constructing hundreds and hundreds of decision trees, and that requires a lot of training time. And here comes one more disadvantage, is that the interpretation becomes really complex when you've got multiple decision trees. So decision tree interpretation is easy because it is an individual decision tree. But when you combine hundreds of decision tree to form a random forest, the interpretation is really very difficult to understand, and it becomes quite complex to apprehend what exactly the model is trying to predict and where the splitting occurs and what features are being selected and so on. And another disadvantage is that it requires more memory. So memory utilization is really heavy in case of random forest because we are working with multiple decision trees. And another disadvantage is that it is computationally expensive and requires a lot of resources because of the training of multiple decision trees and also storing them. All right, so this was all about random forest, the theory part of it. And now let us just move on to the practical demonstration or a hands-on on random forest. Okay, so now it's time for a hands-on on random forest. So let us just import a few basic libraries of Python in our Jupyter notebook, and we will run this. We will import pandas as PD, numpy as NP, and seaborn as SNS. Now seaborn is needed here because we want to load a data set, that is a penguins data set, with the help of seaborn. And this is already been preloaded in seaborn. This is already loaded data set, and seaborn has got multiple data sets, for practice for beginners. So it is a good way to practice for data sets. Now we can see this asterisk sign, that means it is telling us to wait. So let us just let it get loaded. So we got our data in an object called df, and we can see the first 5 entries here. And this data frame is shown in the form of a table, rows and columns. And we see here some species, island, bill length, bill depth, flipper length, body mass, and the sex of the penguin. So our task is to specify or to classify these species of penguins into the respective correct species, right? So we see the shape of our data, and we see that it is like 344 rows and 7 columns. And we will see the info. So we see df.info, and this gives us, along with the non-null count, we also get the data type of the values. So we have got species island as the object data type, whereas the bill length, bill depth, triple length, and body mass are in floating point, or you can say floating data type, and the sex is in object data type, right? So now moving on forward to calculating how many null values are there with the help of df.isNull.sum. So we get certain some around 2 null values in all these columns, as you can say, the features like bill length, bill depth, flipper length, and body mass, whereas there are 11 null values in sex feature, right? So what we do is, since they are very small null values, we can just drop it, or you can also ignore them. So here in this data frame, what I'm doing is I'm just dropping these null values, and let us just check whether they are being dropped or not with the help of, again, the same function .isNull.sum, and then we see that yes, they are being dropped from our data frame. Now let us do some feature engineering with our data. Now we have seen that we have got some object data type in our data frame, and before feeding it into algorithm, that is random forest, we have to transform the categorical data or the object data type into the numeric. So we are using here one-hot encoding to convert the categorical data into numeric. Now there are various ways in Python which we can do that, like one-hot encoding, or you can also use a mapping function in Python, but here we are using one-hot encoding. So let us just do that. And we find here, first of all, let us apply it on the sex column. And here we see that we have got 2 unique values in sex, that is male and female. And we use pandas here to get dummies. That is how we will apply this one-hot encoding, because this is how get dummies work. So what happens is here is that the new unique values are converted into the respective columns in the data frame. So we see here we have got two unique values, males and female, and they are being converted into the columns. Okay, so one thing to note here is that we also get a problem of dummy trap, because here we see only two unique values. Now suppose if I had 6 or 7 unique values and I do this one hot encoding, I would have lots of features in my data frame, and that would lead to several complexities. So what I do is, to keep things simple, I can use one hot encoding when my data frame or my unique counts are low, when my unique values are less. So since I had just 2 or 3, I can use it. So I'm using here. So what I do is, again, now one row, one column, as we can see here, that it is redundant, giving me extra information. So I will just drop it. So I drop this first column, and what I get in this data frame is only male. So let us just infer whether I can also infer females from this or not. So if the value is 1, that means the penguin is a male. And if the value is 0, that means the penguin is a female. Okay, so only one column is needed for this data frame. So I just kept one and dropped the another one. Okay, now apply again one hot encoding to the island feature. So in island, if we check the unique values, we've got 3 unique values here: 𝐓𝐫𝐚, 𝐵ISCO, and Dream Island. And the object is the data type, right? So again, we will use pandas, pd.getDummies, and we will apply it on the feature island, and let's get the head of it. So we get here, again, the unique values were converted into columns, and we get here respective 3 columns. And then again, we will just drop the first column to get the remaining 2 columns. So here also we can infer that if the island is 𝐓𝐵𝐚, if it is 1, then it is not Dream, neither 𝐵ISCO, right? So this is how we can read it from the data frame and understand that. Now remember this thing, that these 2, island and here sex, these are 2 independent data frames. These are not yet included in the main data frame. So what we will do now is we will concatenate the above 2 data frames into the original data frame. So what we do, we again create a new data frame, that is new data, and let us just concat with the help of pd.concat function, and we will concat what? df, island, and sex. And access is 1, that means in the column. Okay, so when we will run this, let's see the head of it. So everything gets concatenated in a single data frame, which is good for the feeding this data into, or splitting the data into test and train data. So now we have this new data frame, and we've got some repeated columns here which needs to be deleted. So what we do is we will delete sex and island here, which are just repeating, because we've got here male, and we have also got here Dream and 𝐓𝐵𝐚. So we do not require this island column, neither this sex. So we just drop it with the help of new data.drop and the column names x is 1 in place equals to true, right? And let's see the head of this data frame. Head of the data frame gives me 5 unique values, right? And now it is time to create a separate target variable. And what we'll do is we will store in a variable called y only species. So what we do is from this new data.species, we will just store the species in this y. And we see this y.head, that is the first 5 species. And we got the values here. That means another target variable is being created now. So, and you can also see the y.unique values as 𝐓𝐵𝐚, 𝐶hINSTRAP, and 𝐵𝐴𝐻. So now we see here 3 unique values of the penguin, that is 𝐿HINSTRAP, 𝐓𝐵𝐚, and 𝐵𝐴𝐻, and the data type is object here. So again, we need to convert this object into the numeric data type. So now what we are doing is we are using the map function in Python, and what we do is we map 𝐓𝐵𝐚 to 0, 𝐿HINSTRAP to 1, and 𝐵𝐴𝐻 to 2. So this is how we see then all the values are being mapped to numeric. This is another way to convert a categorical value into a numeric value in Python. Now what we do is, let us just drop the target value species from our main data frame. So we just drop it, and let's see our new data frame. So we see that we don't have any target species here, right? Okay. So in X, let's store this new data and perform the splitting of the data. So what we do is from sklearn.model selection, we will import our train test split, and we will split our training data into 70% and 30%. So test data becomes 30% and training data is some 70%. And this random state is 0, which means that I'm not fixing any random state. And this is also used for the code reproducibility. Now suppose if I again run this code, I will get the same result. It will not change. You can set this random state to any of the random number as per your choice, and the result would differ. Okay, so now let us print the shape of X-train, Y-train, X-test and Y-test. So we see here that it has been split into 70 and 30%, and we get X-train as 233 values here and 7 features, and X-test has 100 values and 7 features. Similarly, Y-train, you can see 233 values and Y-test has 100 values. That means the species. Okay, so that has been perfectly splitted into 70 and 30%. Now what we do is we will train the random forest classifier on the training set. How do we do it? We will import the random forest classifier from sklearn.ensemble. So we've already dealt with what is ensemble. And then in classifier, we will store this random forest, and this n estimator is nothing but decision trees. So we are creating some 5 decision trees here, and the criteria is entropy. And again, random state is set to 0. So let's see. And then we will fit this X train and Y train. So this has been fitted and the criteria is entropy here. All right. So now let's make some predictions, and let's create a variable called yPredict, and we will just predict it on X test. And we have also printed this Y prediction. And now let's print the confusion matrix to check the accuracy of random forest algorithm. And what we do is from matrices, sklearn matrices, we will import classification report and confusion matrix and also the accuracy score. So we will just import them, and then in CM variable, we will print the confusion matrix of Y test and Y predictions. So we will print it, and we see here the accuracy score also, which is 98%. So our random forest classifier is giving us a very good accuracy of 98%. And you can see your confusion matrix that only 2 cases have been misclassified. Rest all the cases have been correctly classified by random forest classifier. Okay, so now let's move on to printing the classification report of Y test and Y prediction. Let's see. And we get the precision as 96%. That means the true predictions by the algorithm is 96%. The recall or the true prediction rate is 100%, which is very nice. And F1 score is also good, which is 98%. So this is giving us a good result. But what if we change the criteria from entropy to Gini? So let's just experiment with that too. So let's try this with the different number of trees and change the criteria to Gini coefficient. So now again from sklearn.ensemble, we will import random forest classifier and fit it. Okay. And here what we are doing is just we are using 7 trees. Previously we used 5. And now in the criteria, we will use Gini coefficient and random state is 0. So let's run this and see whether there is a change in accuracy or not. And let's predict this. And let's check the accuracy score. What is the accuracy score for this random forest classifier with 7 trees? So we get 99% accuracy with changing the criteria and changing the number of trees. So you can just experiment with different number of trees and different number of decision trees. Let's just experiment with 12 decision trees and see what happens. So you can see the accuracy reduced to 98%. Okay. With 7, we were getting 99. So let's just keep 7 because it is giving us really good accuracy. So this is about random forest classifier and how it works with several trees and different criteria to give us very good accuracy on our training and test data. So this was all about random forest classifier, and this is it from my side. Thank you for watching.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!